A common question that is quite asked in the world of large language model building or production is the difference between RAG and fine-tuning, when to use what. So we'll quickly go over what each of these mean and roughly give a breakdown of the make a pros and cons list for the topic. So essentially, let's start with RAG. RAG. The best way to look at RAG is essentially someone who has complete agency, who has complete autonomy to go and retrieve any information that they do not have access to at the moment. So essentially, let's say if it's a student or if it's an intern or if it's someone that is very curious, they already have some prior knowledge. They have some prior knowledge, let's say, but then now they're being tasked with some new information, so new questions, but they don't fully know the answer. They don't fully know the answer to. So they have two options. One is study the content to get the answer. Two is go and retrieve information that is related to that option. That is essentially what RAG is in the context of LLMs. LLMs have been trained on a specific set of data set already, so they have a vast amount of pre-knowledge about a lot of topics, but they don't necessarily have domain expertise at certain topics. And so for a more clear example, LMs may not have information about your company policy. And if you want to build an internal chatbot, you would want your LM to have complete uh, domain expertise in your company policy. So you would want your large language model plus company policies. And in order for you to do that, you would need you would need to allow the LM to go and access your company policies so that they can answer the question. So the way it would work is user has a question, it asks the LLM, and then the LLM is able to go and fetch this data that is stored somewhere, and then is able to convey it back to the user. That is essentially on a very high level how RAG works. Let's look at fine tuning. So let's do fine tuning. Fine tuning is essentially building on is a subset of a concept called transfer learning, where you essentially take a model that has weights that has been pre-trained and has determined weights and is already relatively doing really good, but now you want to further train it on a specific set of data. One really common example is something called instruction-based tuning, where you want your large language model to behave a certain specific way. So we are aware that large language models take advantage of something called system prompts, where even if you give them a bunch of different prompts, system prompt is the one that keeps constant. So it's basically like that. For when for any instruction-based tuning, you would give it a set of instructions. You would then give it the prompt, and then there would be some sort of labeled data set. And so based on this instruction and these two components, it will be trained to behave in that sort of manner. So this could be classify the following as a spam or non-spam. So then this data set would have certain text that should be classified as spam and certain that's not in spam. And this would have a prompt that says, hey, here a spam or non-spam filter that does X, Y, Z. This instruction will be baked into this model so that from the day the fine tuning is done onwards, whenever it sees a blur of text, it will instantly go into its spam or non-spam filtering mode and try to detect if it's spam or not spam. So the way it would work is essentially you would have a user, you would talk to the LLM, and then the LLM would just do a response back. Generally, basically how we interact with ChatGPT, Claude, and whatnot. So when to use what? When to use what? Oh, I cannot type. When to use what? I think the best way to look at when to use what is what's your context. what it is that you need. So RAG is very easy and quick. So RAG is quick and easy. Cloud providers such as AWS, and I know for a fact Azure has made it really simple for any developer, any manager to set up a RAG system very fast, very quickly. So if you want to just prototype some sort of some sort of model, prototype some sort of business use case using using RAG, that is very easy to do, very low in resources, and it will get the job done as in terms of expectations of a POC, not necessarily something for production. So that's one reason. Another reason why you could use RAG is if your data is constantly changing. So let's say if you have a real-time database that is constantly updating, and you want your large language model to have access to that updated data set, you would want to use RAG. Why? Because RAG is essentially a pipeline that allows your large language models to uh, large so RAG is essentially a pipeline that allows your large language models to have access to your data pipelines. It is not something that's already built into the LLM. So whatever happens here does not matter to the large language model because it will just essentially just use this RAG methodologies to go and retrieve that information. So I think these are the main reasons why you should use RAG. Oh, and one more topic I think is perfect. If you really value precision. So if it's some sort of lookup, like similar to company policies, or it could be something very more specific, like medical terminologies or whatnot, and you would want your large language models to not generate an answer, but rather go pick out. So you would want your LLMs to not necessarily generate an answer, but you would want your LLMs to go learn, search in a document what that term means or what that answer is, and then relay that back to you. That is when you use RAG. On the contrary, fine tuning. I believe fine tuning has less use cases than RAG. I think fine tuning is only viable is if you know for a fact that you want fine tuning is what you need. You've tried RAG, you've done the quick and easy stuff. You know your data is not changing constantly, and you want something called an instruction-based model where you want to do some sort of classification on it. That is when you would want to fine tune. So it's when you have, lack of a better way of saying it is, you know this is what you need to do. So it could be sometimes that you are kind of confused that, hey, I don't know how I know this. I think then the best way to do this, go about this is try out RAG. If that does not work, or you see that, okay, you're happy with RAG, but your data is not changing. You don't really value precision. You just want a very easy way to, you just want some sort of this interaction here. You don't want this external interaction here. Then I think it's perfect to go and fine tune. But some things to keep in mind when doing either of these are the main drawbacks. The main drawbacks of RAG would be the process of how you set up this pipeline. So RAG has two methodologies that we can take advantage of, which is just normal vanilla RAG, just call it VRAG, and then we have advanced RAG. So advanced RAG takes advantage of chunking, embedding, embeddings and indexing to do a really good job of building this retrieval system. So then, and a lot of libraries give you a lot of flexibility in modifying that indexing bit, that chunking bit, that embedding bit, that retrieval bit, and how the data is stored after chunking and all that process. We're not necessarily dive into how RAG works in depth, but essentially just a quick overview of what the differences are and how you can differentiate the two. So that is how RAG would work. But then the drawback of that would be if your data becomes really big, then you might end up the consumption of token might skyrocket because essentially when you retrieve this information, it just becomes system prompt plus the retrieved data. So if this retrieved data just keeps getting bigger and bigger and bigger, this entire system prompt is just going to keep getting bigger and bigger and bigger. So you will constantly hit your system. You will soon enough you will constantly be hitting your token limit, which should rack up. On the other side, fine tuning drawbacks are a bit more. One is the resources, because essentially when you're fine tuning a model, in a way you're basically training a model from scratch. So you would need the computing resources, you would need the knowledge resources of doing it, the accuracy, the math, the time. So again, it comes back to, if this is something that you know you have to do, that is the only case you do it. I would say fine tuning, that is the biggest downside of fine tuning, is the resources it needs, the computing resources, and just the lack and just the ability and just technical knowledge of training a model. Whereas this is very quick and dirty and easy to go. So some tools that we can use to do reg are Ollama. So we can use Ollama to do this. We can use Llama Index. Actually, not Ollama. Ollama's for something else. So we can use Llama Index to do this, and then we can also use Haystack to set up pipelines for reg. For fine tuning, I know PyTorch has something called TorchTune, so we can use that. We can also take advantage of anything that some things that Hugging Face made. I think it's called PFT. This essentially is a much bigger topic where you want to optimize how you do this using QLoRa or like LoRa and yeah, basically LoRa techniques, low ranking optimization. I'm not really too sure about that topic yet. But yeah, so essentially reg is very easy, quick to do if your data is constantly changing and you just want your LLMs to be connected. And if you just want your LLMs to be connected to your data, that's when you use reg. Fine tuning is you've tried reg, you know your data is not constantly changing. You have a lot of data, you have a very big data set, and you don't want to blow up you don't want to blow up the token limit. And you just want a simple LLM interaction for your user. That is when you do fine tuning. Okay, thank you.